In this video, we will talk about how to determine heart rate during ECG reading. We have three main methods to determine the heart rate. Before we go through this, we should understand some basic calculations. Now, the standard pepper speed is actually 25 millimeters per second. Okay, that's being said that during 1 second, the ECG machine will eject 25 millimeters. Now, we remember that 1 millimeter equals small square. So whenever we use millimeter, it's the same as small square. So per 1 second, the ECG machine will eject a paper length of 25 small squares. All right. Now, if we look at here, during 1 second, we eject 25 small squares. So 25 small squares per 1 second is actually 0.04 seconds per small square. Okay, so it is 1 second divided by 25 small squares that will be ejected during this time. And so each small square needs 0.04 seconds to be ejected. Now, 0.04 is the same as 40 milliseconds, because if we want to convert from second to millisecond, we multiply by 1,000. Okay, so 0.04 seconds is equal to 40 milliseconds. Okay, so just to remember these numbers, how we convert through them. All right, now, so the 0.04 seconds is actually the same as 40 milliseconds. So for each small square, it needs 0.04 seconds to be ejected from the machine. Now, we remember that one large square, if we look here, one large square is actually 5 small squares, right? So when we say one large square is actually 5 small squares, meaning that to eject one large square, we need 0.05 multiplied, 0.04 multiplied by 5, which is the 0.2 seconds. So to eject one large square, it takes 0.2 seconds, or is the same as 200 milliseconds, but we don't use 2 milliseconds here. Just, I'm telling you this just to understand. Now, so for one large square, we want 0.2 seconds. All right, so for one total second, how many large squares would be ejected? If each large square needs 0.2, meaning I need 5, for 1 second, it will eject 5 large squares. Okay, so 1 second, the ECG machine will eject 5 large squares. Now, the heart rate, when we determine the heart rate, it is measured for 1 minute, right? When we say like 70 beats per minute. So the unit that is used is not second, it's minute. Now, each second, sorry, we eject 5 large squares. So during 1 minute, I'm gonna eject 300 large squares, okay? Because each second, the ECG machine is ejecting 5 large squares. And in each minute, I have 60 seconds, meaning that 60 multiplied by 5 equals to 300 large squares per minute, okay? This is important. Now, we remember that the large square, each large square has 5 small squares. So per minute, I'm ejecting 300 large squares, which is the same as 1,500 small squares, because 300 multiplied by 5 is 1,500. So in 1 minute, take home message, in 1 minute, the ECG machine is going to eject 300 large squares, or the same as 1,500 small squares. Okay, now the golden rule here is standard record is only 10 seconds, meaning that whenever you are recording the ECG tracing for a patient, the paper length that the machine is ejecting is equal to 10 seconds. The ECG machine will never record for 1 minute unless you tell it to do so. Okay, for any standard ECG, the length of the paper is equal to 10 seconds only. All right, so from these numbers, we will give you 3 methods to determine heart rate. Okay, and when we are talking about these 3 methods, we are going to illustrate them all of them, and we'll give examples on them. And we will start from the least accurate to the most accurate one. Okay, the first one that is least accurate is the large square method. It's an easy one, and it's very fast, and it only works when you have a regular rhythm. Okay, how we can use that? No, it's very easy. You measure how many large squares between two consecutive R waves. Let's say there are two large squares. And the equation is easy. You say 300 divided by how many large squares you have. So 300 divided by 2, the heart rate will be 150. All right, just like an example. Now, the other method is more accurate. It's called the small square method. It's the same, actually. You remember that during one minute, you have 1,500 small squares, right? So how we can calculate the heart rate? It's easy. You measure how many small squares between two R waves, and you divide 1,500 divided by how many small squares you have, and you will have the number, okay? Now, the most accurate method that you have to always use it, because it is also used for the regular rhythms and irregular rhythms, is the R wave method. It's very easy. You just calculate all the R waves in the ECG strip. And whatever number you have, you multiply it by 6, because you remember the ECG machine eject a paper of 10 seconds, right? And so how many R waves you have, this is only for 10 seconds. And you wanted to convert these 10 seconds to 60 seconds, which is 1 minute, right? So you multiply by 6. All right, let's take an example for this, and we go from there. Okay, let's have this ECG. When we are looking at it, it seems that it's regular, right? The distance between two R waves are equal all the time. So we can use all the three methods to calculate them. Okay, let's start with the first method, which is the large square method. Let's take, for example, this R wave here and this R wave here. How many large squares in between? It's two large squares. The first one is here. This is the second. And there's a little bit more. Okay, but let's say two large squares. So the equation is easy. 300 divided by 2. And this is give me 150. Remember, this number is not accurate. It's close, but not accurate. Okay, 150. Because you can see there are like a few small squares here, but we are not giving them here. We are not putting them here. Okay. Let's go for the second method, which is more accurate, but not the best, but it's accurate, which is the small square method. How we can use that? Let's use the same RR wave, RR interval. We have here large square, which is 5 small squares, another large square, which is also 5 small squares, and I think we have 2 small squares here. So we have total of 12 small squares. So the equation is easy. It is 1,500 divided by the number of small squares between the two R waves. And 1,500 divided by 12 is 125. This number is more accurate than 150, but still not the best. The best method is to count all the R waves you have. 1, 2, 3, 4, 5, till the end of this ECG rhythm till here, you will have 22 R waves. Okay, so 22 multiplied by 6, this give me 132. And this is the most accurate ECG rate, okay? So for this patient, his heart rate is 132, not 150, nor 125, but they are close enough, okay? At least all the numbers says this patient has tachycardia. All right, what about this ECG? Again, still the RR interval seems regular, meaning that the distance between two R waves are the same. So we can use the three methods. Let's start with the first method, the large squares. I have an R wave here and an R wave here, and in between 1, 2, 3, 4, 5, 6, 7. So I say 300 divided by 7, and this gives me 42. Okay, what about the small square method? You can see here, it's exactly 7 large squares. And each large square is 5 small squares. So 7 multiplied by 5, this gives me a 35 small square. So I say 1,500 divided by 35, this also gave me exactly 42 beats per minute. And the most accurate method is the R wave method, which you calculate all the R waves, 1, 2, 3, 4, 5, 6, 7, and you say 7 multiplied by 6, and this gives you 42. Look here, all of the three numbers are the same because the ECG is pretty regular. All right. What about this in this case? You can see here that the RR interval is not regular. Look here, it's very broad here, and here is very short, okay? We can't rely on the first and second methods because they will give us a very inaccurate numbers. So because if you use it here, the patient will have bradycardia. If you use it here, the number will indicate tachycardia. So the most reliable method is the third method, which is the R interval method, R wave method. How we can use it? Let's calculate the numbers of R waves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 R waves multiplied by 6, and this gives me 78. Okay, so this is the most accurate number that you can have for this patient. And that's it. This is how we calculate the heart rate during the ECG recording and the ECG interpretation. Thank you.